Welcome to this video lecture on the subject Optical and Microwave Engineering. So in this lecture we are going to discuss about optical fibers and acceptance angle and numerical aperture. So first of all we should understand ray theory of transmission. So in optical fibers, total internal reflection is the basic principle used for fiber communication. So refraction occurs during when a ray is incident on the interface between two dielectrics of different refractive indices. So for example, glass and air, so refraction occurs. So the angle of incidence and angle of refraction is related by Snell's law of refraction. So it is given by n1 sin phi 1 equal to n2 sin phi 2, where refractive index of the medium is defined by the ratio of velocity of light in a medium divided by velocity of light in a vacuum. So in this picture we can see three different ray transmission diagrams. First one, we have a incident ray and there is a refraction on the exit ray. So here we use two different medium. One is high refractive index of n1 and low index of n2. So when wave is incident from high index medium to low index medium, so refraction occurs at this particular angle and partial wave is internally reflected. So this is one phenomenon of ray transmission. In the second diagram, so here the wave incident at an angle of phi c, it is known as critical angle. So it is known as the angle at which the ray is transmitted, and it is on the other side it is traveling parallel to the interface. So this is known as the critical ray of angle. And next case is the phenomenon where total internal reflection occurs. So this angle will be greater than the critical angle. So at this angle the ray is internally reflected on the other side. So this is known as the total internal reflection. So the wave travels through the fiber using this principle. So first, critical angle. So as n1 is greater than n2, the angle of refraction is always greater than the angle of incidence. So thus when the angle of refraction is 90 degree, the refracted ray emerges parallel to the interface between the dielectrics, as we have seen in the previous diagram. So the angle of incidence must be less than 90. So this is the limiting case of refraction, and the angle of incidence is known as the critical angle. So this relation is given by sine of angle critical. It is equal to n2 by n1. And next is the total internal reflection. So when the light is incident on the dielectric of lower index from the dielectric of higher index at an angle of incidence greater than the critical angle. So propagation of light wave through optical fibers. So any light wave which travels along the core and meets the cladding at the critical angle of incidence will be totally internally reflected. So therefore the light is propagated along the fiber core by series of total internal reflection. So it is given in this diagram where the light is travels through the core with series of total internal reflections. Next is acceptance angle. So meridional ray enters the fiber core at an angle of theta a, where theta is refers as the acceptance angle. So incident ray B at an angle greater than theta a is refracted into the cladding and eventually lost by radiation. So if any ray is lost by radiation, it is greater than the angle of theta a. And an acceptance angle defined by the conical half angle theta a as given in this picture. So where theta a is the maximum angle to the axis at which light may enter in the fiber in order to be propagated is called as the acceptance angle of fiber. And next, numerical aperture. So numerical aperture of the fiber is the light collecting efficiency of the fiber, and it is the measure of the amount of light rays that can be accepted by the fiber. So it is equal to the sine of acceptance angle. So it is given by this relation of n0 into sine theta a, where it is related by n1 and n2 or the refractive indices of core and cladding respectively. A numerical aperture of the step index fiber is n1 into root of 2 del. Thank you for listening. Assessment for this lecture is: what is the numerical aperture of the fiber if the angle of acceptance is 16 degree? So the answer is it is calculated from the relation between numerical aperture and acceptance angle, where it is sine of the acceptance angle. So sine of 16 it is equal to 0.2. So the answer is option D. Thank you for listening.